Now on the next one, if we look at this, is g of x equal to 2 times f of x, or is this f of 2x? Do you guys agree with Sean? Bottom one? All right, so if this is 2 times f of x, this would be 2 times x. But what would f of 2x be? What happens if we replace x with 2x? Could be either one, right? So if we look at this, would this be a vertical or horizontal shift then if we consider it to be 2 times f of x? Vertical. So we'd look at each point was twice what it normally was. If we look at this as a horizontal shift, f of 2x, would this be a stretch or a compression? By what factor? All right, you got it, Mindy. Compression by 1/2. Now you look horizontally. Each point has 1/2 the x value of what it had before. So this one is it's just a special case where you could look at it either way.
So why is saying that it rotates counterclockwise bad?
No, there's not a rotation counterclockwise. You could look at it. It does. If you just look at the final result, it looks like it for this case. But if you do this in more general situations, this is a horizontal or vertical stretch.
Okay.
On that.
You couldn't say increase the slope.
You could. That kind of goes back to treating it as mx plus b. I mean, this is just kind of pointing out that you could look at it as a stretch and compression. But one of these problems would have been sufficient just to point it out. I didn't need to do as many. If you look at the bottom problem, then the same thing. You could look at this as 1/2 f of x or f of 1/2 x. So this would be a vertical stretch with a factor of 1/2. Or if you looked at this as f of 1/2 x, it would be a horizontal stretch now of 2 because it's always the inverse. And so each x value doubles. If you look at it as a vertical, actually this would be a compression.
I was going to say, if it's 1/2, it's gotta be.
Yeah, you guys are on it. Good. A 1/2. Each one is 1/2 the y value. So that's good. You're catching my mistakes on there.